Gain control of cyber risk with Tenable.io, the first vulnerability management platform built for today's elastic assets like cloud, containers, and web apps. Discover a fresh, asset-based approach that prioritizes vulnerabilities while seamlessly integrating into your environment. And improve ROI with the first elastic licensing approach based on assets, not IP addresses. Tenable.io delivers the data and context you need to secure your elastic attack surface. Start your free Tenable.io trial today by visiting Tenable.io. In order to deliver the maximum degree of privacy, personal data must be protected without action from an individual. In fact, this requirement is defined in the General Data Protection Regulation, also known as GDPR. What if you could reliably and efficiently build privacy into your information security programs by default? StealthBits Technologies provides solutions that allow data to be collected and used in a manner that achieves GDPR compliance. Privacy by design and by default is not just a GDPR requirement, it's the foundation of StealthBits Technologies. Visit stealthbits.com to learn more today. Welcome back, everyone, to Enterprise Security Weekly. After the show, I'm going to throw my teleprompter out the window. But in any case, two quick announcements. Two websites to go to: wildwesthackinfest.com, October the 27th and 28th, I believe, in South Dakota. Black Hills Information Security is putting that on. Wild West Hackinfest, HACKIN fest.com. Also, check out Domain Tools, domaintools.com/Security Weekly. They're putting on a fantastic webcast, which I'm very much looking forward to, that really talks about mining data from domains, who is data, IP addresses, and using that effectively in your organization. Two very smart people from Domain Tools will be on to present that information. domaintools.com/Security Weekly. If you are a security professional that has not played around with Docker yet, but your developers are either looking into it or they're actually doing stuff with Docker today, it presents an opportunity. I'll speak about really just one of those opportunities. I do have some example, a Docker file and a run command in the show notes for this episode, wiki.securityweekly.com. It's what I'll be reading from for this segment. And really what I want to highlight are some opportunities to do system hardening and application hardening if you're moving down the Docker path, which I think a lot of people are going to do. And basically, you've heard us talk in the past how when developers are setting up the environment, there's an opportunity for them to become sysadmins for a day. And these are some of the opportunities. And this is one of the things I really like about Docker is that when you define your container, you can be very specific about what's in your container. I think for hardening and security, this is a huge win all around. I think it's one of the reasons why DevOps, we're moving in that direction, and it's having a positive impact on security. So you'll see in my example Docker file, I'll just go through a couple of things. First of all, I'm building a Debian system, use system in air quotes. I'm building a Debian system on the fly. I'm not pulling from the centralized Docker repository for this and just installing, in this case, Nginx. I'm actually building a new Debian Jessie system and running the command apt-get update on that system. So every time I go to build this particular container, I'm going to run the update command and get all of the latest software, which that in and of itself, huge win, right? There are issues if I'm pulling an existing, so if I just did, hey, from, the Dockerland build Nginx, I'm getting whatever version comes down. Now, there are ways to do that more securely. I like to build the actual platform itself from scratch and update it. I then run an apt-get command to install some tools. So I'm installing like wget, nettools, vim, and supervisor. That's all I need. And this is what I love about hardening with Docker is I can just specify that this piece of my application, which is just the web server, only needs these specific packages to run. This is great. I mean, this is like hardening 101, but you can script this. Now, this is a Docker file example. In production, you'd probably use a Docker Compose, or if you're really brave, Kubernetes. But in this example, the point is you're going to specify just the few packages you need to run Nginx in its own container. It's great. So I install Nginx. I copy my configuration files over to this running container as well. Here's another opportunity to manage your configuration, provide secure configuration that's used inside of all of your containers. I then expose some ports, which is just a standard command to expose ports. I'm only exposing the ports that I need for my application. Again, another hardening premise is that I'm only exposing the ports that I need to run this application. And then I'm coming in here, so one of the weird things, and feel free to copy this Docker file and use it and modify it. Primarily, you would use this Docker file inside of your lab. Again, in production, you're probably doing Docker Compose, which we'll cover in future segments. I'm starting the services using Supervisor D because Docker does not support the systemd. So I've installed that and configured that to put my Supervisor D config file on the system and then run Supervisor D, which is going to control what services run on the system. Again, another opportunity to make sure only the services you need are running inside of this container. Then I do some interesting things, and this is good but somewhat scary from a container and virtualization type security scenario. This particular container, I'm now defining what the networking should be. And, obviously when you're using Docker Compose, you define the networking for your entire suite of applications, as Apollo was referencing, I believe, in a previous segment. For this simple example, basically this Nginx Docker container needs an external network connection, so this is what users will connect to. I'm creating a MAC LAN bridge, putting it on my local network. I'm defining a MAC address. I'm saying privileged equals true, which allows you to actually do things on the system you normally wouldn't be able to do. And then mapping ports 80, 80, 80, and 443 to my external IP address. And then I'm linking it to my other container. In this case, it happens to be my application server container. That's the internal networking that you can define within Docker as well. And it links to my application. And that's where the separation gets kind of weird. It's got an external connection, and then the internal link to my application server, which isn't exposed directly to the network. The only way to use this application is to go to Nginx and access the web server. I then define some local storage containers. In this particular application, I need an uploads folder. I'm telling it, because multiple containers have to access the same set of files in a particular directory, I'm specifying that directory exists locally on this host system, and then multiple containers can access that directory. That's also kind of scary from a security perspective. However, it does allow you to control what various containers can share. In this case, it's my uploads directory. I'm telling it to run a particular container with a particular tag, and then I'm connecting to the internal network. So I have an internal network set up between my containers so that they can talk to each other. And there's another Docker command to do that. So not only have I defined that I want this particular version of the operating system, I want it to be updated, I want to install just these packages, I want to expose just these ports, I want these specific configuration files. I've said start it in this way, share only this directory between these containers, store that locally, and I've said connect it to the internal network. I can be very specific how I build my application environment, which if you think about how traditional hardening has worked, it's always been somewhat difficult. I think Docker makes that easier, and that's just a little glimpse into how you're able to configure Docker containers in order to have a secure configuration. I think it's an opportunity. So if you haven't played around with Docker, that's some of the very basic premises that you can use. Now you can go to your developers and ask them how they're configuring their Docker containers, and hopefully reach the point where you understand it yourself and are making recommendations from a security perspective to say, hey, as we learn more about Docker, applications should be configured this way. Configuration, the operating system should be configured this way, and it's very easy to implement that in your Docker environment. So again, the notes and my examples are in the wiki.securityweekly.com. If anyone has comments, suggestions, and or feedback, please send them to psw@securityweekly.com. That will conclude this episode of Enterprise Security Weekly. Thank you, everyone, for watching and listening. See you next time.